This is half past paper, week 20, higher tier, and another non-calculator this week. So this week we're doing all the even numbers. Last week we had the odd numbers, and so together they make up the full past paper. For 80 marks, we've got 39 marks on this one, all the even numbers, and these are all the topics that we're going to have a look at today. Okay, question number 2. This squiggly E means our universal set. So the universal set, all the numbers you know about in the universe, your universe right now, are the even numbers less than 19. So I'm going to write them out. 2, 4, 6, 8, 10, 12, 14, 16 and 18. Less than 19 wouldn't include 19 anyway, but we're only looking at even numbers, so we're going to go up to 18. A is 6, 12 and 18, and B is 2, 6, 14 and 18. Complete the Venn diagram. So the bit you always want to do first is your intersection, this bit in the middle here, and in there we can put a 6 and we can put an 18 because both A and B have those values. We're then left with 12 in A and 2 and 14 in set B. Now we can't forget about all of the other numbers in the universal set because this box needs to have all of those numbers in it. So let's just work through. We've got 2, 4, 6 we've got, 8 we need, 10, 12, 14, 16 and 18 is there. So those 4 numbers that weren't in A or B need to go on the outside. Now sometimes they ask you for the probability of picking a number from A intersection B. If that was the question, we're talking about picking a number from this middle part here, and there are 2 numbers there out of 1, 2, 3, 4, 5, 6, 7, 8, 9 all together. If they asked you the probability of picking a number from A union B, that means anything in A or B. And there are 1, 2, 3, 4, 5 numbers there out of 9. So those are really common questions that they like to ask you normally as a part B. They didn't today, but be wary of those. This is the intersection, just the bit in the middle, and this is the union, which means you can take numbers from either of the 2 circles, including the bit in the middle. Okay, question number 23. At the end of 2017, the value of Tamara's house was 220,000 and the value of Raheem's house was 160,000. At the end of 2019, the value of Tamara's house had decreased by 20% and the value of Raheem's house had increased by 30%. At the end of 2019, whose house had the greater value? You must show how you get your answer. So if this was a calculator paper, if I wanted to decrease by 20%, I'd be timesing by 0.8 because I want 80%, so I would be just timesing by 0.8 to get that straight away. And again, with an increase of 30%, because you would want 130%, I'd be timesing by 1.3. But the problem with that is that we don't have a calculator for this paper. This is a non-calculator paper, so we're not going to do it that way. We're just going to find out what 20% is and take it off, and we're going to find out what 30% is and add it on. So 10%, to get 10%, we always divide the value by 10 if we're starting on 100%, which we are here. So at the end of 2017, for Tamara, let's do Tamara on the left and let's do Raheem over here. So Tamara's house was 220,000. Now 10% of that would be 22,000 and we need 20% for Tamara. So we're going to double that. 20% would be 44,000. Now her house has decreased by 44,000. So we're going to do £220,000 take away 44,000. Now 0, 0, 0, 0 take 4, I can't take away. If there's more on the floor, you need to borrow from next door. 10 take 4 is 6. 1 take 4, again I'm going to borrow from next door. 11 take 4 is 7. And 1 take 0 is 1. So Tamara's house in 2019 is now worth 176,000. Let's now look at Raheem. So he had his house worth £160,000. And we know that 10% of that is 16,000 because we're dividing by 10. So 30% is going to be 3 times bigger. Now 16 times 3 is 48. 3 times 6 is 18, carry the 1. 3 times 1 is 3, add the 1 is 4. So this is going to be 48,000. And his isn't going down by 48,000, it's actually increasing, going up by 48,000. So I'm going to add that on to his starting value, 160,000, add 48,000. 0, 0, 0, 8, 10 and 2. So there we go. At the end of 2019, Raheem's house is now worth 208,000 and Tamara's house is worth 176,000. We need to answer their question, whose house had the greater value? And that was Raheem. And we can see that in the values there. Okay, question number 25. The diagram shows a prism. The cross-section of the prism is a right-angled triangle. Now the cross-section is what we call that shape that you see all the way through a prism. So if I was to slice it here, if I was to slice it here, you'd get that same shape the whole way through. The base of the triangle is 5, and we can see that the shape is 25 long in this direction. Now, the prism has a volume of 750. To get the volume of a prism, it is the area of that cross-section multiplied by how far back it goes. And they're telling us the answer to that is 750. So I know that the area of that triangle, times by 25 equals 750. So let's work backwards here, and I'm going to start by doing 750 divided by 25. Now if you get a division and you don't like it, or it's quite big numbers, I would always write it as a fraction, and then you can just simplify the fraction. So both of these things are divisible by 5, so if I divide by 5 I get 5 on the bottom. 750 divided by 5 is 150, and then 150 divided by 5 is 30. So we now know that the area of that triangle has to be 30 centimetres squared. Now on the picture we're shown that this is 5 centimetres. And we don't know the height, that's what we're trying to work out. And we know that the area of this is 30. Now remember, for a triangle we do base times height, but we divide it by 2 to equal 30, which means that the base times height must be 60. So what would we need to multiply with 5 to give 60? It would need to be 5 times 12. 60 divided by 5 is 12. So 12 times 5 would be 60, which then when you divide by 2 gives the area of 30. So 12 is the answer that you were looking for there for that one. If you put 6, it's because you forgot that when we work out the area of the triangle, we have to divide by 2. Question number 8, solve x squared equals 5x add 24. Now this is an example of a quadratic. We can see we've got that x squared, and because we've got that x squared, the x and the number, this is feeling like something we either want to factorise or use the quadratic formula. But before we can solve this quadratic, we need it to equal 0. And at the minute, we don't have all of the terms on one side and 0 on the other side. So what we need to first do is sort that out. So I'm going to imagine that I've got a dotted line where the equals is, and what you're doing to one side, you're doing to the other. So I'm going to take 5x away from both sides. My advice would be to keep that x squared positive if you can. So I've got x squared minus 5x equals 24. And then also take the 24 away from both sides. So x squared minus 5x minus 24 equals 0. And now that it equals 0, we can factorise it. Because this is a non-calculator paper, it's probably not going to be the quadratic formula. It has come up a couple of times, but when it's been the quadratic formula on a non-calculator paper, it's said leave your answer in the form 5 or a plus or minus root b or something like that. So there would be a bit of a clue. For this, we're just solving it. It's leading me to believe that I can factorise it. So to factorise, I'm going to draw an arrow off of the constant term. And I'm going to write 1 times 24, 2 times 12, 3 times 8, 4 times 6. Those are my different factor pairs that times to make 24. Now I'm looking for one of those pairs that could also make minus 5 if I get the signs the right way round, and that's going to be the 3 and the 8. So I'm going to put x minus 8, x add 3. And if you put x add 3, x minus 8, so the other way round, but still with the minus with the 8, then that's absolutely fine. Once we've factorised it, we're saying I want this multiplied by this to equal 0. So either this first bracket needs to equal 0 or the second bracket needs to equal 0. What value of x here would make the whole bracket equals 0, well, x would need to be 8. So if x was 8, that would make the whole thing 0. Same with this bracket. What value of x here would make it equal 0? And that's going to be -3. So x equals -3 is your other solution. Question number 10. The diagram shows a shape made from 6 identical squares. The total area of the shape is 5,406. Find an estimate for the length of one side of each square. Now, if we're estimating on the non-calculator paper, we're going to round to one significant figure. However, on this question, I know that the first step I'm going to do is to divide by 6. So I'm actually going to round this to 5,400 because that's in the 6 times table. I know that 54 is in the 6 times table, so it just makes sense to me to round to 5,400. Normally we round to one significant figure, but that's going to be 5,000, and 5,000 is not going to be in the 6 times table, so I'm just going to round to 5,400. So I'm going to say this area is 5,400 roughly, so roughly equal to 5,400 centimetres squared. 5,400 divided by 6 is 900. So I'm now saying that each square has an area of 900 centimetres squared. And then I'm looking for something times something that multiplies to make 900. And I know that they're all squares, so it's going to be the same number. So you can think of that as doing the square root. So that's going to be the square root of 900. Something times something that makes 900 is going to be 30. So the length of each side, one side of each square, give your answer correct for the nearest whole number. Okay, cool, we've gone for 30 there. Is your answer to part A an underestimate or an overestimate? Well, what did we round? We took the area and we rounded it down. We said that the area of this was actually less than it is. So we therefore are going to get an answer that's a little bit too small. So our answer is an underestimate because we rounded the area down. So when you're estimating on the non-calculator paper, just make the numbers nice and easy to work with. Okay, question number 12. The cumulative frequency table gives information about the heights in centimetres of 40 plants. Draw the cumulative frequency graph. Okay, so they've actually already done a lot of the hard work here for us. Lots of you will know that when we do cumulative frequency, we add it up as we go along. But they've actually done the adding up here for us. I know that because it says cumulative frequency instead of frequency. And if you look at all of these categories, they all start from 0. So the adding up has already been done. So that means that we can go straight ahead and plot it. Now, when we're plotting cumulative frequency, we plot at the top of the category. So we're going to go across to 5 and up to 4. So across to 5 and up to 4. Always check what you're going up in. This is 10 little squares is 10. So we are going up in 1, so that's okay. Across to 10 then and up to 11. Across to 15 and up to 24. Across to 20 and up to 34. Across to 25 and up to 38, and across to 30 and up to 40. There we go. So we're going to get this nice smooth S-curve, and you can join it to the origin or not. It doesn't make any difference with regards to the mark scheme. Ooh, there we go. Perfect. Okay, brilliant. Use the graph to find an estimate for the median height. Now the median is the middle. So we want the height of the middle plant. Now there were 40 plants. We were told that in the question. It also added up to 40. So we are going to go, technically the middle would be between the 20th and the 21st. But with a graph, we're just going to read across at 20. So I'm going to get my ruler, read across at 20, hit the graph and then go down. And then whatever value that is, that's going to be my median. Now, just pay very close attention. The temptation here would be to go 14, 13, 12. Okay, and that's not going to be correct. We can see that we've got 10 squares making up 5. So that's 11, 12, 13, 14, 15. I've got 13.5. There would have been a range of answers available on the mark scheme. So as long as you've gone across at 20, hit the graph, gone down, and you've read that accurately, you're likely to be in range, but I will check the mark scheme on that one to get the range for you. Question number 14. Here is a shape with all its measurements in centimetres. The area of the shape is A. Show that A is 2x squared, add 24x, add 46. And it feels like this comes a little bit from nowhere, but actually we are going to do the area. We're going to ignore this entirely, and we're going to try and come up with that on our own. So what I want to do is look at this shape. Now, because it's an L shape, I do want to split it. You can split it this way and get the area of this bit and the area of this bit and add it together, or you can split it this way and get the area of this bit and the area of this bit and add it together. It is entirely up to you. I think I'm going to go that way. It looks slightly easier to me, but it really doesn't matter. If you went the other way, that's fine. So this top bit, I'm okay to just work this out. This is 4 and this is x add 1. So I'm just going to multiply those together. 4 lots of x add 1 would be the area of that top bit there. For the bottom bit, we can see that it's got a width of 2x add 6, that's okay, but I don't know what the height is, because remember this x add 11 is going all the way up to the top here, and I don't want to use that for that bottom rectangle. But what I do know is that this bit up here is 4. So therefore, what's left here, if I take 4 away from x add 11, this is x add 7. So therefore, I'm multiplying 2x add 6, that's the base, by x add 7, that's the height. Let's expand that out. 2x squared, add 14x, add 6x, add 42, and then we're going to add on this area as well, which is 4x add 4, because you're doing 4 lots of x and 4 lots of 1. There we go. Collecting all of that together, the area is 2x squared. Got x squareds coming from there, and then I've got 14x, 6x and 4x. They're my like terms. They will come together to make 24x, and then I've got 42 add 4, which is 46. So there we go, that's what we wanted and we've got it exactly the same, 3 marks. Question number 16. There are only 3 red counters and 5 yellow counters in a bag. Jude takes at random 3 counters from the bag. Work out the probability that he takes exactly 1 red counter. Okay, so he could do this in 3 ways. He could take red, then yellow, then yellow. He could take yellow, then red, then yellow. Or he could take yellow, then red. Those are the 3 different pathways. Now you can, if you like, draw a tree diagram. It would look like this, because you've got the first pick, the second pick and the third pick. So it's going to be a pretty big tree diagram. If you did draw that, these would be the pathways that you'd be looking at. So what I'm doing here is, because it's quite a big tree, I'm just thinking about the routes that I would want, and I'm not having to draw the whole tree out, but it really doesn't matter. If you want to draw the tree out, you can. I'm just trying to save a bit of time and a bit of energy here. So there are only 3 red counters and 5 yellow counters in the bag. So there's 8 counters altogether. And we are not putting them back in because Jude is taking at random 3 counters from the bag. So you can't take the same counter. So let's look at this scenario first. If I want to take a red counter first, that's going to be 3 out of 8. We would times that by the next probability. Now, how many yellows are left in the bag? Well, there's still 5 because I took a red out. But it's now out of 7 because there's 1 less counter because I took a red out to begin with. To take another yellow, if I just took a yellow here, there'd now be 4 yellows and there'd be 6 counters left in the bag overall. Okay, now what you're going to see is that all of these probabilities are the same, but it's still a good way of, we still want to work them all out just to see. Okay, so let's look at the next one. I've got yellow, then red, then yellow. So the probability of me taking yellow from the beginning is 5 out of 8. Times by, now the probability of red, there are 3 reds, but it would be out of 7. And then I want to take another yellow, and there's 4 yellows left out of 6. Okay, and last but not least, I want a yellow, that's 5 out of 8, times by the probability of taking the next yellow, which would be 4 out of 7, times by the probability of taking a red, which would be 3 out of the 6 counters left in the bag. And you'll notice that they're all the same. It's all slightly 8, 7, 6 on the bottom, 5, 4, 3 on the top in whatever order, okay? So all of these are going to be equal, and we can times them together. So 3 times 5 is 15, times 4 is 60, and 8 times 7 times 6, now that's slightly trickier. 8 times 7 is 56, so I'm just going to do 56 times 6. This was a non-calculator paper, so 6 times 6 is 36, and 6 times 5 is 30, add the 3, so 336 is your denominator, and at least we only have to do that once for all of them because they've all got the same denominator here. So then for the next one, 5 times 3 times 4, again, we're just going to get 60, and 5 times 4 times 3, again, we're going to get 60. Adding these together it's going to be 180 out of 336. You don't add the bottoms. When we add fractions, we make the denominators the same, and then we just add the tops. So 180 out of 336. Yes, that can be simplified, but you do not need to. For probability, it's absolutely fine as it is, and it's probably quite nice for the examiner to see those numbers that you needed to get, so I would leave it like that for 4 marks. Question number 18. Here's a trapezium, ABCD. The area of the trapezium is 66 centimetres squared. The length of AB to the length of CD is in the ratio 2 to 3. So this is 2 parts and this is 3 parts. Find the length of AB. Okay, so what do we need? We really need the height. For the area of a trapezium, it's A plus B, which are the 2 different widths, the parallel sides, divided by 2 times by the height. That's how we work out the area of a trapezium, and we know that that equals 66 because they're telling us that the area is 66. So what do I need? Well, I need the height for sure, and then that's going to help me to work out what this bit is, and that's going to help me work out the missing widths that we want there. Okay, so what is the height? Well, the height is that value there, and so what we're going to do is SOHCAHTOA in this right angled triangle. This is the non-calculator paper, so I'm expecting that we would need to use exact values at some point, sine 30 or cos 30 or sine 60 or cos 60 or what have you. So yeah, one of those is likely to come up, and here we can see we've got 30 degrees. That's a bit of a clue that we need to do exact values or SOHCAHTOA with those values. Okay, I want this side here, which is the opposite. I've got the hypotenuse, so that's helpful information, and the adjacent would be this bit down here, but I don't know it and I don't want to know it, so that's not going to be very helpful. With your SOHCAHTOA triangles, you've got SO, CA and TOA, and if I want to know what the opposite is and I've got the hypotenuse, I'm going to use SO. Cover up the thing you want to know, so in this case we want to know the opposite. If I cover that up, I'm left with S multiplied by H, and so I'm going to do sine 30, because that's what the S stands for, sine of the angle, multiplied by the hypotenuse, which is 6. Now you are expected to know that sine 30 is a half. So a half times 6 is 3, and therefore we know that the height here is 3. Okay, so I now can pop that here and say A add B divided by 2 times by 3 is 66. Great. Let's change this to be 2x and 3x. We don't know how long either of those sides are, but I know they're in that ratio. Then I can pop those values into here and work out what x needs to be. So 2x add 3x divided by 2 times by 3 is 66. And if we divide both sides by 3, we can see that this needs to be 22. So 5x divided by 2 is 22. Let's times both sides by 2. 5x is 44. And then we're just going to go ahead and divide both sides by 5. So x is 44 divided by 5, which is the same as 88 divided by 10. I think that's the easiest way to do it. So 8.8 is x. That means if we know that the top one is 2 lots of 8.8, that's 17.6. And if I know that the bottom one is 3x, we would do 3 lots of 8.8, but I don't need to. Find the length of AB was the question, and that is my answer. So 17.6, 8.8 multiplied by 2 was 17.6, and that would be your answer. 5 marks for that one. Okay, question number 20. The diagram shows the graph of x squared add y squared is 30.25. Use the graph to find estimates for the solutions of the simultaneous equations. So simultaneous equations on a graph are just where the two graphs cross each other, where they intersect. Now they've already drawn this one on the graph for us, and we need to draw this one so that we can see where they cross. Now y minus 2x equals 1 is not that easy to draw. So what I'm going to do is change it so it's y equals 2x add 1. All I've done is added 2x to this side and added 2x to this side to make y the subject to the formula. I can now see that this is a straight line with a gradient of 2 and a y-intercept of 1. So that means it's crossing at 1. That's my y-intercept. And for every 1 across, this is the definition of gradient. If the gradient is 2, that means for every 1 across, it goes 2 up. So 1 across, 2 up. 1 across, 2 up. 1 across, 2 up, and so on. But once you've got a few points, you can just fill them in and then use your straight line tool just to draw that line, something like that. There we go. Okay, so then we're looking for the 2 places where they cross, or it might be 1 place where they cross, but in this case we've got 2 places where they cross, and that's going to allow us to answer the simultaneous equations. Now, each of these is going to have an x and a y. I'm going to be super accurate here. Am I? I don't know. Let's go for, yeah, it's going to be 2.1 across. That's my x value. If you look down here, that's 2.1 is the x coordinate, and the y coordinate is 5.1. So I'm going to write on the answer line, x1 is 2.1 and y1 is, I forgot the number immediately, 5.1. There we go. So they go together. Then we need x2 and y2, the second x and the second y, because they go together. So this value here, we're going to get a similar thing. This is the x and this is the y. So I've got minus 2.9 coming from here and minus 4.7 here. So minus 2.9 and minus 4.7. There we go. Again, there might be a range of values that they allowed for that. I'll double check the mark scheme and pop it below. Okay, question number 22. Last one on this paper. Find the coordinates of a turning point on the curve with equation y equals 9 add 18x minus 3x squared. You must show all your working. Now this is completing the square, but it's quite a tricky one. I'm going to turn this round. Minus 3x squared, add 18x, add 9. Now that's exactly the same as what they've given me. I just prefer to work with it with the x squared term first. Now if ever you have a number in front of x squared and you want to complete the square, you need to factorise it out. So I'm going to put minus 3 outside a bracket and then x squared minus 6x, and then I'm going to shut the bracket and add 9. Now some of you will want to bring this in as well. Depends how you've been taught it. It's completely up to you. I personally like to leave it on the outside, but it does not matter, okay? Now I've not completed the square there. All I've done is get it to the point where the x squared is on its own. Now I'm going to complete the square on what's inside those square brackets. So to complete the square, we half this number. So it's going to be x minus 3, all squared, and then we take away this number squared, so minus 9. Now I'm just going to bring this back in to each part. So that's minus 3 lots of x minus 3 squared, add 27, add 9. So then that would be minus 3 lots of x minus 3 squared, add 36. They want the turning point, and the turning point is found by whatever value of x makes that bracket equal 0, and then whatever this number on the end is, that's your y. So this is going to be 3, 36. So the opposite here, whatever makes the value equal 0, and then just whatever that number is, that's your y. So 336 was the correct answer there. I think the hardest bit of that was maybe realise if you take minus 3 outside, this positive needed to factorise to be a minus 6 just to make that correct when you expand it out. That's quite tricky. And then it was at this stage that I completed the square. But that's very much a grade 9 question. Completing the square is the topic. You can do more of those on Maths Genie. There's lots of questions on Maths Genie, but it is grade 9, very, very tricky. So well done if that made any sense, hopefully. Let me know in the comments if you've got any questions. I'd be happy to help. And I hope you guys enjoyed it, and I will see you next week for week 21.